In addition to applying this definition graphically, I'd also like to get some practice in applying this definition algebraically. So let's look at example 3 here. It says let f of x equal 1/2 x plus 3. For each epsilon greater than 0, show that the limit as x approaches 2 of f of x is equal to 4 by finding the corresponding delta greater than 0 such that absolute value of f of x minus 4 is less than epsilon whenever 0 is less than absolute value of x minus 2 is less than delta. So again, the thing I would start with here is let's identify what x value we are approaching, our c, and what is our limit. Here in this case, x is approaching 2, so I would say, hey, c is 2. Let's make a little note of that. And our limit here in this case, the limit that we're approaching is 4. So in these problems, we're going to start with what we know. So we know epsilon, we know our function f of x. So I'm going to start with this piece right here. I'm going to actually take my function and my epsilon value and plug that in. So let's just rewrite this here. I have absolute value of f of x minus 4 is less than epsilon. So I'm going to take the value of f of x and the value of epsilon. We'll plug this in. So absolute value of f of x, well, f of x is 1/2 x plus 3 minus 4 is less than epsilon. In this case, we're going to say that epsilon is 2 here. And my goal here is to end up with something that looks like this side over here. I'd like to isolate x in a way almost. I'd like to get that coefficient of x out of there. So I'm just going to do a little bit of algebra here. First, I'm just going to combine my like terms. I have 1/2 x. I've got positive 3 minus 4. That's really a minus 1 is less than 2. My next step here, I say, okay, I'd really like to get rid of this 1/2 right here. I'd like to get rid of that somehow. So I'm going to factor that out. And this might be a little bit tricky here because we're going to factor a fraction this time. But I'm going to factor that out. And the way I'm going to do that, I'm going to pull that out. The first term, that's no problem. It's just going to get rid of the 1/2. Minus over here, this one might be a little bit tricky because remember when we factor something, we're actually dividing by that number. So when I take 1 and actually divide it by 1/2, dividing by a fraction we know is the same as multiplying by the reciprocal. So dividing by 1/2, really the same as multiplying by 2 over 1. So this would be x minus 2 here. Oops. X minus 2 inside of those parentheses is less than 2. And you should be able to go back and check your answer here. If I took this 1/2 and distributed this through 1/2 times x, I would get the 1/2 x. That's what I want. And if I took 1/2 times negative 2, I would end up with negative 1. So we're all good to go. I know that I factored this correctly. Let me erase this here. So the next thing I'm going to do is I'm going to use properties of the absolute value to take that 1/2, that constant multiple, out from there. So I'm going to pull that apart here. So say absolute value of 1/2 times the absolute value of x minus 2 is less than 2. And hopefully we're looking at this, we're saying, boy, this looks an awful lot like this guy up here, right? This looks an awful lot like x minus 2. That's what I want. I'm trying to get rid of this. So let's continue on. Let's simplify what we can. I know that the absolute value of 1/2 is just 1/2 times the absolute value of x minus 2 is less than 2. I'm almost there, right? I want just absolute value of x minus 2. So let's get rid of that 1/2. I'm going to multiply both sides by 2 over 1. So I'll multiply both sides by 2. On the left-hand side, those two would cancel, which is what I want. And on the right-hand side, I've got 2 times 2 equals 4. So this says absolute value of x minus 2 is less than 4, and hopefully we should end up with exactly the same thing as we've got up here, right? We've got absolute value of x minus 2 is less than delta. Here we've got absolute value of x minus 2 is less than 4, which means that I can just look at that inequality and now say, well, in this case, delta should be 4. And that is my answer. That is my solution to this problem. So really what this is saying is if you pick a number that's within 4 units of the x value, c equals 2, and plug that into your function, you will be within epsilon equals 2 units away from our limit, which is 4. So just to kind of show and pick apart what this definition is trying to say here, if I pick a number that's within 4 units of 2, right? So I'm thinking about c minus 4 and c plus 4. So 2 minus 4, that would give me negative 2, and c plus 4, 2 plus 4 would be 6. If I pick a number between negative 2 and positive 6 and plug that into my function, I should be within epsilon equals 2 units away from 4. So let's actually just try this real quick before we move on to our next example. This is not anything that you need to show me, but I just want to show you kind of what we're doing here. So if I took any number between negative 2 and 6 will work. You can even try other numbers here. I'm going to try x equals negative 1 here. I'm going to take x equals negative 1. I'm going to plug that into my function and then subtract 4, check the distance. So, let's look at f of negative 1 here, which is 1/2 times negative 1 plus 3. I have negative 1/2 plus 3. 3 is really 6 over 2, so this is actually 5 over 2, a positive 5 over 2 here. And if I take this now and I look at, okay, absolute value of f of 1 minus 4, this should be less than 2. I don't know right now, but I'm actually going to show whether it is or is not less than 2. So f of 1 right here, or excuse me, f of negative 1, forgot my negative sign. When I took negative 1, plugged that into my function, I ended up with 5/2, so we know that this value is 5/2 minus 4 should be less, we don't know, should be less than 2. 5/2 minus 4, 4 is really, what is 4? 4 is 8 over 2, so I have 5 over 2 minus 8 over 2 is less than 2, so this should be negative 3 over 4. So in this case I have absolute value of a negative number, makes it positive, oops, not negative 3 over 4, excuse me, negative 3 over 2. So this becomes positive 3 over 2, which I know is 1.5 for those of us that prefer decimals. And when I write this as 1.5, that value is absolutely less than 2. So if I pick a number within this interval between negative 2 and positive 6, plug that into my function, I'll land within epsilon units, in this case 2 units of my limit, which in this case is 4. Let's look at one more example here. So I have another function, g of x is equal to negative 5x minus 2. For epsilon equals 1, we would like to show that the limit as x approaches 1 of g of x is equal to negative 7 by finding the corresponding delta greater than 0 such that absolute value of g of x plus 7 is less than epsilon whenever 0 is less than absolute value x minus 1 is less than delta. I have a little typo there. This should really be delta. So let's go and find our delta. So again, you might look at this piece right here. You might say g of x plus 7. That looks a little bit different than our definition. But what this is really saying is it's really saying g of x minus negative 7, which is how we come up with the plus 7, because our limit here in this case is negative. So don't worry about that plus sign here. That's not going to, impact our problem a whole bunch here. So let's take g of x, we'll plug this in, so absolute value of negative 5x minus 2 is my g of x, plus 7 is less than epsilon, which in this case we're saying is 1. So we'll simplify what we can on the inside of that absolute value. Here, negative 5x, negative 2 plus 7, I've got plus 5, is less than 1. And again, I'm trying to end up with something that looks like absolute value x minus 1, so I need to get rid of that coefficient of a negative 5. So I'm going to factor that out first. Absolute value of negative 5 times the quantity x minus 1 is less than 1. This is looking good here. I see that x minus 1, which is what I want. But I have to take apart that constant multiple of negative 5. So this really says absolute value of negative 5 times absolute value of x minus 1 is less than 1. And then from here, we just have a little bit of algebra to do. I know that absolute value of negative 5, that's really positive 5. Absolute value of x minus 1 is less than 1. And I'm just trying to solve for that absolute value x minus 1, which means we need to get rid of the 5. So we will simply divide both sides by 5. So if I go over here to finish my problem, I should end up with absolute value x minus 1 is less than my delta, which in this case is 1/5. So I can conclude then that delta is equal to 1/5. So there is my solution to this example.